Hello, 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 hello.
point. And the reason for this, among other things, is that it allows us to be a bit more flexible about how the player starts, so that if we were trying to play test our level and wanted to start off already on the cliff, we could right click on the cliff and go play from here. If you try that out right now, you'll notice that actually you just end up where we've placed the character. And the reason for that is that Unreal doesn't actually know what character we want to use. Now, the way this typically gets solved is with a class called a game mode. A game mode is essentially an actor that goes into your level and controls the rules for the game. It tells it how to do things such as who should spawn where, what class we're going to use for the player, as well as many other classes that define how our game works. And in multiplayer games, it can control things like how many players are allowed in a given game. It can also control win conditions, so things like capture the flag tends to be a game mode, or battle royale may be a different sort of game mode. These are what we mean by the rules of a...
They're not moving anymore. Wait, it's not associated with the blue. What? It lost connection with the C++. Why happened? Maybe I have to recompile. I just closed the project and open. What the fuck? What is happening? File everything. Am I drunk? Everything is moving at the same height to the same side. Oh, okay. So instead of using the... We lost the configuration. Why? Oh, this is so fucking annoying. think that might be too fast. So good. Oi, oi, oi. File. Why did it do that?
Particular game or a particular match. Now, if we go to the toolbar and click on the blueprint drop-down, you can see that under the project settings and under the world override, there is a menu item called game mode. So we've got a setting for the project as a whole, which tells us what is the default game mode for any level that we create within our project. And then we have the world override, which tells us this is the game mode for this particular level. So you can see that at the moment we are using something called the BP Learning Kit game mode. And that's included with the kit and the project that we created. So what we actually want to do is go and create our own, and we're going to do this in Blueprint for the time being, but it is possible to create game modes in C++, and we will do that later on in the course. So let's go to the project settings game mode menu item, and then go over to the create submenu, and then what we're going to do is we're going to select a base to base this actor class off of. And the one I recommend you use is new. We'll do settings and under the bits that define how a game works. And in multiplayer games, it can control things like how many players are allowed in a given game. It can also control win conditions, so things like capture the flag tends to be a game mode, or battle royale may be a different sort of game mode. These are what we mean by the rules of a particular game or a particular match. Now, if we go to the toolbar and click on the blueprint drop-down, you can see that under the project settings and under the world override, there is a menu item called game mode. So we've got a setting for the project as a whole, which tells us what is the default game mode for any level that we create within our project. And then we have the world override, which tells us this is the game mode for this particular level. So you can see that at the moment we are using something called the BP Learning Kit game mode. And that's included with the kit and the project that we created. So what we actually want to do is go and create our own, and we're going to do this in Blueprint for the time being, but it is possible to create game modes in C++, and we will do that later on in the course. So let's go to the project settings game mode menu item, and then go over to the create submenu, and then what we're going to do is we're going to select a base to base this actor class off of. And the one I recommend you use is the game mode base. It's the one with the most minimal settings and things included, so we don't get anything we don't need. So we can click on the game mode base to create a new game mode. And we got to choose a name like we would for creating any other actor blueprint. So we're going to call it BP, always starting with that BP prefix when we're creating blueprints. And it's going to be BP underscore obstacle assault game mode. And I'm going to put that in the root of the content folder and hit save. And now it's going to open up into its own tab, and you can see that it is really just the actor tab, so exactly like any other actor. And the interesting thing is if we go
everything's an actor.
Have a look at the properties and settings of the actor itself, you can see that there is a section called classes. And this is what dictates what player we can have spawned into the world. So this is what we want to change. We want to find particularly this section called the default pawn class. We've talked about how pawn is essentially the player that you play with. So we're going to, instead of the default pawn, select the drop down and look for the BP third person character. That's the character that we've created. And we're going to set that as the default. Then we're going to hit save and go back to the main level. Go to the blueprint drop down, and you can still see we have this world override for this particular map. We want to clear that so that the default project game mode is the one that's going to be used. So let's select the world override and go to where it says select game mode class, and we're going to go and select none. So now in the drop down, if you have a look at it, you can see that it's saying that the game mode is not overridden and we're using the project defaults game mode instead. However, if you right click somewhere in the world and click play from here, it's still not going to work. And the reason for that is we still have this character in the level that wants to take over, essentially, because we've told it to, and we don't have any player starts. So I'd like to challenge you to fix that by adding a player start, remove the current character from the scene, open up the Place Actors panel, and drag in the player start actor, then test it out and see if when you play, you start from the player start, and also see if you can right-click somewhere and click play from here and see if that works too. Pause the video and have a go. Okay, welcome back. So going to start off by deleting the character here. Got my Place Actors open. Obviously, we can do that from the quickly add to project button in the toolbar and open the Place Actors panel that way. And we can drag in a player start into the scene, so place it in roughly where the character was. Hit play, and boom, our character is spawned in. Now, what about that right-click menu option? So I'm going to go on top of our platform, right-click, play from here, and here we are, right on top of the platform, allowing us to play test our game far more easily than if we had to go through the entire level every time. Great stuff. We've developed a bit of an understanding of the game mode class, really crucial in Unreal game development. I'll see you in the next lecture. Hello and welcome. In this lecture we're going to be looking at how we can write things to the output log, and specifically how we can write the values of our variables into it that can help us debug our games. Let's dive in and see how this works. So in Blueprint, we were able to write things to the screen when we wanted to quickly display some information or potentially to just debug something. In the past, we have in C++ used a U property to do that, but we can actually do this using a log statement. And it's a little bit complicated in Unreal, which is why I've shied away from doing it until this point, so we're a bit more familiar with the C++ syntax before introducing it to you. Now, the way it works is if you've got the extension here installed, the Unreal for Snippets by Captain Caps, this actually gets a little bit easier because you don't have to remember all of the complexity of the syntax. You just type ulog and it will pop up with an IntelliSense dialog like this saying ulog to help you write out the whole piece of code, and you can hit enter or select it with your mouse, and then what you're going to see is it's written out something that looks a bit like a function. It's not actually a function under the hood. It's got a little bit of Unreal magic going on here, but it's essentially a bit like a function. So what we're going to do here is we're passing in a couple of arguments to this function. The first one tells us what type of log category we are doing. The second one tells us the level of the log, so how urgent it is essentially. And then finally, we've got this thing here, which is basically a function within a function, which tells us the text that we need to print out. So how does this work? If we just leave this in our code, go over into Unreal, hit compile, we want to see where does it show up. Well, once the compilation has finished, we're going to go ahead and hit play. And what you're actually looking for is it's not going to be up on the screen here. It's going to be in the output log down here. And you can see it just about here. It's saying display your message, and we've got how many messages? 1, 2, 3, 4, 5. The reason for this is it's displaying the message for every single actor in our scene that is a moving platform CPP. So that is why we're getting so many messages. And you can see we can change out the message to be whatever we wanted it to be here. And we could also put some more information into this message, such as the start location or the name of the actor, things like that. So here we go. We've got an output log, we've got our message, and you can start to see what the categories I was talking about are. You can see we've got log temp here, but up above we've got log audio mixer.
Of the log temp. Wait for me to clear this. And then we can change the color probably based on the log kind, log type. Warning. Pretty cool.
Log world. So there are different categories of logging that help us distinguish where is this message coming from, which part of Unreal is this coming from. But log temp is mostly what we're going to use because it's just a temporary place for logging out debug messages. And then there's display. This is the default level, log level, but we can have messages be a bunch of different things. It can be display or any value from this table down here. So you see display here, it prints a message to the console. and the log file. We've got the log down. Here, which prints a message only to the log file and doesn't display it in the console. So this is for things where you don't really want it to show up so much, but might want to use it for debugging. If you're debugging someone's game and it ran on their machine, they're sending you a log file. Then you've got warning. This is for when things seem to be going wrong, and it prints it to the log console, and it is also in yellow. Then we've got error, that prints it in red, and then fatal basically prints to the console and crashes the engine. So you kind of want to use this one as a last resort, but it does allow you to have different levels in the log file, and I'll just show you what it looks like if we put in different messages here. So I'm going to copy our line for logging. I'm going to make 3 of them. We're going to have a display, we're going to have a warning, and we're going to have an error. Now these are typically the levels that we will use, so let's go ahead and have a look and see what they look like. Let's go into Unreal, hit the compile button, and let's stop and restart play. And by the way, you can bring up the output log by hitting the tilde key twice. It brings up, there you go, we've got our output log, and you can see we've got 3 sets of message: the display, which is just in the plain white, warning, which is in yellow, so it stands out a little bit more, and error, obviously, which stands out a lot more. Now we can add data to our log messages. I'm just going to delete the warning and error lines of the log, and we can add in some data into this string that's going to be printed out. The way we would do this is, for example, if I wanted to print out the move distance configured for a particular platform, that's fairly straightforward to do. We can say configured move distance, and that's the text that's going to show up. I'm going to put a colon in here, and remember this is all within the double quotes to make sure that we're including it in the text. And then we can use a % sign followed by the F character. And you see that gets highlighted differently because this is what is known as a format specifier. It's something that comes from C all the way back in history. And essentially, usually you do a % sign and then some letter. You can see the different letters down here. The F corresponds to a decimal floating point, and you can see an example of what the output looks like over in the example column. And there's lots of other things down here. We can represent with D or I a decimal integer like so. So we're using F because we've got a floating point number. And then what we have to do is add in another argument to the UE log function. So make sure that you are doing this after you've closed the brackets for this text function, and instead we're putting a comma after here. So between these 2 brackets, it should be inside of the outer set but outside of the inner set, if that makes sense. And then what we can do is we can pass in the value of our variable, so we can do the move distance variable like so. Let's go over into Unreal and see this in action. Hit the compile button, close down the compile window, and hit play, and then hit tilde twice to bring up the log, and you can see our configured move distances showing up for the different platforms, 500 and 500 for the 2 moving platforms, and 1500 for the 3 pushers that we've got in the scene. So one piece of information that might be a little bit interesting or instructive is that we've previously talked about how we overshoot, or we did overshoot, the distance moved. And it'll be interesting to know by what kind of levels that is happening. So what we could do is we could create a float variable inside the if statement, so we know that we've currently overshot. We can say overshoot, a float variable called overshoot. We're going to set it equal to the distance moved minus the move distance, so that tells us how much the overshoot was. So I'd like you to have a go at logging the overshoot variable that we just created here. So use the UE log function. Here it is for reference, at least the kind of structure that you will probably be using. You can also practice using that ulog autocomplete to put it in instead, and then compile and test your code and see if it works. Pause the video and have a go. Okay, welcome back. So we're going to use the autocomplete option here. I'm just going to close down my sidebar to have a little bit more space. And then inside this if, after we've created the variable, we're going to type ulog and hit enter. And then we're going to leave it at display. We're going to make the...
Wait a second. Run. Oh shit.
Text.
Okay, overshoot. Let's...
Platform overshot by, and then we're going to use %f, and then between these two brackets we're going to add a new argument for the overshoot variable, like so. Now let's head back into Unreal, hit the compile button, close down the live coding log, hit play, and double tap that tilde key, and you can see that every time the platform is turning around, it is printing out a log message and saying how many units it overshot by. You can actually see, and in a lot of cases, it's overshooting by quite a noticeable amount of units. 3 units or 0.5 units, that's basically 0.5 of a centimetre, 3 centimetres. It's enough that over the course of your game, these platforms could have been drifting.
Yeah, it's
and
a
that's
lot.
great that we've implemented a fix for that already. Great stuff. So hopefully now you've got another tool in your arsenal for trying to
Depending on
figure out
the...
what's going on inside your code, and later on, when you are feeling more confident in making your own code, trying to figure out what's not working so well. Okay, I will see you in the next lecture. Hello and welcome. In this lecture we're going to be looking at how we can add dynamic text into our log messages using strings in C++. So let's dive in and learn about strings in C++. So we've seen how to print out some simple things from our UE log, but what if we wanted to print out some more text, something like the actor name, for example, or even something more complicated, such as a textual representation of a vector? Well, that does not typically have format specifiers, because format specifiers have come to us from the age of C, which is a very basic programming language in comparison to C++, and so certain things just weren't thought up at the time. So things like vectors would not be included in the way that we format and specify them, so we tend to use strings to do this. And as we've said in the past, strings are just text variables. They are variables that contain text. So we can declare strings in C++. We've used f vectors where we used vectors previously. Here we're going to use f string as the type for a string. So we can have a string, and I'm just going to put in my string as the variable name for now. And how do we set a string value? Well, we've seen it a little bit around here already. These double quotes are what denote a string value in C++. So all of these expressions here, that one here where we've got the double quotes, also over in the header file where we've got the double quotes for the category, that is a string expression. So what we can do is set the myString variable from this, and I'm going to say myString value just to give us an idea of that, and put a semicolon at the end of the line. And then how can we show this in a log statement? So I'm just going to remove the move distance from here as an argument to the UE log, and I'm going to change the text in the log message to say, here's my string, colon, and then instead of the F specifier, we use %s this time to denote the string that we want to print out. And then the argument we pass into the UE log function, again between these two brackets, is going to be my string. Now, unfortunately, that would be great if that just worked by itself, but unfortunately there's a little bit of a complication here in Unreal that it won't accept a straightforward string as an argument to the UE log. It needs a little bit of a converting operator here, and the way we do this is by putting an asterisk in front of the myString, and it just converts it from an F string into the format that it's looking for internally within the UE log. We don't have to go into too much detail as to why it's doing this. It's beyond the level that we need to know at this point in time. I think it's just important to learn it as it is, that when we do a %s, we always need a star in front of our F strings. So let's see if that's worked by going over into Unreal and hitting the compile button. And then we're going to close down live coding, hit play, open up the output log, and here you go. Here's my string value. So it's string, colon, and then instead of the F specifier, we use %s this time to denote the string that we want to print out, and then the argument we pass into the UE log function, again between these two brackets, is going to be my string. Now, unfortunately, that would be great if that just worked by itself, but unfortunately there's a little bit of a complication here in Unreal that it won't accept a straightforward string as an argument to the UE log. It needs a little bit of a converting operator here, and the way we do this is by putting an asterisk in front of myString. It just converts it from an F string into the format that it's looking for internally within the UE log. We don't have to go into too much detail as to why it's doing this. It's beyond the level that we need to know at this point in time. I think it's just important to learn it as it is, that when we do a %s, we always need a star in front of our F strings. So let's see if that's worked by going over into Unreal and hitting the compile button. And then we're going to close down live coding, hit play, open up the output log. And here you go. Here's my string value. So it's printing out the value in the myString. But obviously this piece of code that I've just written is not particularly useful because, well, I could have just written this string into here. Why bother with this whole substitution business? Well, where this gets more interesting is where we put a dynamic value into this variable instead. So we could do get name and call that. That is a function here available in the moving platform actor that gets the name of the actor that we see in the level outliner. We can put it into the variable. I'm going to call that variable name instead of my string and change its name down here in the UE log as well. So then we can change the text of the log message to say begin, play, colon, and then it's going to be the name of the actor. So let's go back into Unreal, stop play, hit compile, go ahead and hit play and open up the output log, and you can see we get the messages begin play, moving platform 1, begin play moving platform 3, pushing cube 3, pushing cube 5, pushing cube 7. So we've got begin play and all the names of the different actors. Now this can be very useful because later on down the line where we're printing out our overshoot distance, it's not always clear who is overshooting in this case, because they're all getting messed up together. So being able to print out the name of the actor that is producing the log message can be really helpful in pinpointing where a problem is happening. So I'd like to challenge you to log the name with that overshoot log so that we're going to see who has overshot and by how. much. So you're going to add a variable for the name of the actor to tick, like we did in Begin Play. You're going to get name into it, and you're going to add a %s specifier somewhere, anywhere you like, into your log message where we're printing that overshoot. And you're going to add an argument for that name. We still want the overshoot variable in the list of arguments, but after or before that one, you're going to have to put the argument for the name as well. And it's important here that the order of the arguments matches the order of the specifiers in your message. So if you put %s before %f, then that's the order the name should go, before the overshoot. Or you should do it the other way around if you've done the other. And don't forget to add the star before your variable name to convert the string into something that the UE log can use. Pause the video and have a go. Okay, welcome back. So we're going to start off by getting a variable, and this isn't strictly necessary, but we are going to use the variable just for simplicity's sake and keeping that line a bit shorter. So we're going to have an F string called name, using uppercase letters usually to start our variable names. We're going to do a get name into that variable, and then we're going to use it as an argument. But where am I going to put my format specifier in the log message? Well, I'm going to put it as the first thing in my log message to kind of make it clear that this is a log message coming from this thing. So I'm going to put %s first, and that means that my argument needs to go before the overshoot argument. So we're going to get the name, put it in here, and we need to put an asterisk in front of the name in order to convert it appropriately. Now let's go back into the editor, stop playing, hit recompile, close the terminal, hit play, and open the output log. And you can see that we're starting to get our tick messages coming through. Got pushing cube, overshot by 1, pushing cube, 1, 1. So you can see here, you can make a conclusion that we couldn't make before, which is that the faster moving platforms, the pushing cubes, are the ones overshooting by more, whereas the moving platforms seem to be overshooting by less, which is what I would expect, but it's good to see it confirmed here in the logs. Great stuff. So that's it for our little logging diversion. Hopefully you found this interesting, and I will see you in the next lecture. Hello and welcome. In this lecture we're going to be implementing our own class member functions, move platform and rotate platform. We're going to see how we can set them up so they can take in arguments, and it's going to help us tidy up our code a little bit. Let's dive in and see how this works. So up until now, we've been using C++ functions that have already been created for us. We've been using tick, we've been using Begin Play in terms of writing their functionality, and we've also been using functions that other people have written for us. We've been calling them, such as get actor location and get name. Now, how can we go about creating our new own functions to help organize our code and keep these functions small and everything much more legible? Well, we've got the basic building blocks already in place. By getting towards the end of the section, we understand a lot more about C++ syntax. So what I want to do is essentially create a new function on the moving platform that allows us to have, just in tick, say, call move platform. Why do I want to do that? Well, because being able to make a function call like this called move platform, it really speaks to what we're trying to do. At the moment, we've got a lot of stuff going on in tick, and I'm not entirely clear why we are doing all this stuff if I just come and take a glance at it. If I went into tick and saw a function that says move platform, well then suddenly I have the context for what all this stuff should be doing, and I don't need a single comment to tell me what's going on. And this is going to be particularly useful when we add into the mix the possibility of rotating the platform as well. So how do we declare functions? Well, the declaration aspect is done over in the header file. That's where we basically say, heads up to C++, we're going to have a function that's going to look kind of like this. And then over in the C++ is where we actually define the function. We give it the body, we tell it exactly to C++, this is how the function works. And let's have a look at how we can do this. We've got a few examples of functions, and we've got Begin Play, we've got tick, and it's a good point in time for us to look at the different sections that we've got in our header file. We've got public and protected being mentioned here, and public being mentioned again. Now, what does this mean? These keywords with the colon at the end basically define a section of accessibility. These functions, where can they be accessed from? We've seen over in the getSafe normal, this is a function that we're calling on an F vector, but we're calling on it from another class, not from within an F vector. So this means that the accessibility of this function needs to be public. Now, we'll leave aside protected just for the minute because it gets a little bit more complicated there, but there is another type of keyword that we can use, which is private. So I'm going to add, after tick, I'm going to add the private keyword. Notice that I don't indent these sections. and we're going to put a colon at the end. And that means that everything that comes afterwards until the next section, the next keyword that I put in here, is going to be private. So that means we've taken all of these variables and said, hey, no other class is allowed to touch these. And that's usually the best practice. We haven't done it up to this point because I didn't want to get things a little bit too confusing for you. But variables in classes should generally be their own business. It's one of the core tenets of object-oriented programming that we leave classes to manage their own variables and we only access them using functions that the class denotes as being public. So what we're going to do here is we're going to add some more private functions in here because we don't want something like move platform to be called from outside of the class. We want it to be managed by our own tick function. So how do we define a private function? Well, we put it in a private section. So we've got our private keyword up here. I'm going to put it after our variables, however. And we start off with the return type. And if our function doesn't return anything, we just type void to indicate that there's no return coming out of this function. Then we give it a function name. So we had move platform was what we wanted. And then we give it some parentheses to indicate that this is a function. Open and close parentheses, and then a semicolon to finish off the line and say, okay, that's it. That is the function that I want to declare here in the header file. And all that does is says this is the shape of the function, this is the return, this is what parameters it takes, and the name, and which class it belongs to. Now, to actually give it an implementation, we have to define it over in the C++ file, so let's go over there. And at the end of the file, just outside of any curly braces, this is where we do it. We start again with the return type, so that's going to be void. Then, because we're inside a C++ file, we're not inside the curly braces of a class, we have to use the scope resolution operator to say that we're trying to define a function from within the moving platform class. So we type the name of the class, which is a moving platform, remembering that a prefix is there to say that it's an actor. Then we use colon, the scope resolution operator, and then we use the name of the function we're defining, which is move platform. And then we use the same set of parameters as we did in the header file. In this case, we had an empty set of parameters, so we just have the parentheses. And then, instead of putting a semicolon at the end of this line, on a new line, we put an opening curly brace and a corresponding closing curly brace. And between these curly braces is where we put the code for our function. Fantastic. So what I want to do now is try and say, well, all of this functionality we've got here, and in fact, I'm going to delete the comments because we no longer need them. They were the pseudocode we used to implement this, but now it's kind of served its purpose. We understand what the lines of code are doing. I'm going to take everything but the move platform function out of tick and copy it and paste it into our move platform function instead. So this should work pretty much the same because when we go into tick, we then call move platform and it just runs the same piece of code, except now we've bundled it into a function and it makes it easier for us to read and potentially reuse in the future. But if you do this, you will notice there is a problem. We are accessing delta time, and that is a parameter we no longer have access to because it was a parameter passed into tick. So if we want to get hold of that, we do need to have a parameter in our function. So when we define parameters, we have to do it in two places, just like when we define the function. We go back over to the header file, and between the parentheses of our move platform function, this is where we say what parameters we want. And it's exactly like defining a variable. You need to give it a type, and you need to give it a name. So we're going to say it's going to be of type float, and we can just call it delta time. It doesn't have to be the same name. We could call it dt, we could call it time, but it's easier to give it the same name because then it's obvious to anyone reading it what should be passed in here. Then over in the C++ file, we need to match the list of parameters. So again, you can just do this by copying and pasting or by typing it out. If you type it out, make sure you don't make any typos because the compiler will complain. So we're going to have a float called delta time passed in as a parameter or defined as a parameter to move platform. But we haven't actually passed it in as an argument to move platform in tick. And you'll see I've got a little red squiggly line here. I hover over it, it says there's too few arguments in the function call because I've defined it in the header file and now in the C++ as well as requiring one parameter of type float. So I must provide that parameter. So I'm going to make sure that the parameter I'm providing, the value that I'm providing comes from the delta time variable or the delta time parameter from tick. So we're threading the value gets passed into tick, then gets passed into move platform and ends up in our parameter in the move platform function where it can be used to execute our move platform functionality. So I'd like you to create your own rotate platform function that we're going to call from tick. So you're going to add it to the header file like we've done for our move platform function, we're going to add it to the C++ file in the same way as well. So take your hints from the way we did it for those functions, and then call it from the tick function. Make sure you pass in delta time and you define any parameters to allow you to pass in the delta time, and implement the body of the rotate platform so that it logs out a message. It's not actually going to rotate the platform yet, but as a placeholder to make sure that that is actually getting called, print a log message using the UE log that we've learnt about. Pause the video and have a go. Okay, welcome back. So we're going to start off in the header file, and we're mostly going to be doing the same as we did for our move platform. We're going to put it in a private section so that it's only accessible within our class. I'm going to give it a void return type. I'm going to call it rotate platform. We're going to open up the parameter list, and in it we're going to put one parameter, which is going to be of type float. We're going to call it delta time, and close the parameters and finish off with a semicolon. Now, most of what we do over in the C++ file is exactly the same as in the header file. So I'm actually going to copy this line, go over to the C++ file and show you what is different. So I'm going to go to a new empty line at the end of the file, paste it in. And then what's different is over here we need the scope resolution operator in the class name. So we're going to have a moving platform, : rotate platform. Then we have the parameter list, and then we don't need the semicolon on the end. So we remove the semicolon, add in a new line, and add our curly braces instead, and a new line between those two curly braces. So what we want to do in here is print out a log message. So I'm going to type log, hit enter. It's just going to be a simple display message. And in the text, I'm going to put the name of our platform. So it's going to be %s. Then we're going to type rotating ... and then I'm going to pass in the name. Now we could put this into a variable, but because it's quite a short line here, I'm just going to type star get name, and then put the parentheses so that we're calling, essentially here, calling the get name. That is the expression that gets hold of the f string, and then we are converting that result to put into our log message. So from all of our platforms, I'm expecting to see that rotating is printed, but this will only happen if I actually call it in tick. So let's go up to the tick function. After move platform, I'm going to add a new line and call the rotate platform. And we need to, you see when I open up the parentheses, it gives me a hint that I need to pass in an argument for delta time. So again, we're just going to pass that same delta time variable from within here. And like I said, the names here don't have to be the same. So this delta time needs to match with the delta time within tick. But we could choose to call the variable within rotate platform dt instead, and anywhere we use it within rotate platform, we'd have to use dt. The name of the parameter and the argument can basically be different. So let's hop over into Unreal and hit compile. Because we've made some changes to the header file, the compilation will be slightly longer than when we just changed the C++ file. And once that's completed compiling, we're going to go ahead and hit play and open up the output log. And you can see that we are indeed displaying log messages about each of the platforms rotating. So it looks like our function is effectively getting called in tick. Great stuff. Now we understand how to create our own functions that are members of a class. It's a very useful tool for reusing our code, but also for organizing it, just like it was in Blueprint. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be looking at how we can return values out of our functions using different return types and a return statement. Let's dive in and see how this works. So last lecture we said that if our function doesn't return a value, then the return type should be void, which is what we've done here. But what if we wanted to take a function such as basically checking whether we should turn around? You know, this function here in the if statement, if we could say should turn around instead, it would be a much cleaner function at the end of the day. So how do we do that? How do we achieve a function that can return a Boolean expression? Well, the way we do it is simply by using a type instead of the void. So if we were to want to return a Boolean expression, we could type bool, like we would for a variable. But the thing that distinguishes the function from the variable is the fact that we put parentheses after it. That makes it a function rather than a variable. And what we could do is call it should platform return. And then we put our parentheses, and in this case, I don't have anything that I want to pass in as an argument to this function, so I can just leave the parameter list empty, put a semicolon at the end of the line, and then copy this entire line and go over to the moving platform CPP. And right at the end of the file, you could put it anywhere you like, really, between any of the functions. Just make sure it's not inside a function. I'm going to paste it in here. I'm going to unindent it. And I'm going to add the class and the scope resolution operator. So a moving platform should platform return, then remove the semicolon and add some braces instead. And what we want to do here is if we want it to actually return a result, we need to use the special keyword return followed by an expression of the correct type. So in this case, it has to be a Boolean expression. So I could return true and then put a semicolon at the end, or I could return false and then put a semicolon at the end. But it doesn't have to be that simple. It could actually be any expression. It could be another call to a function. It could be a variable. It could be a use of some operators as we have up here inside our if statement. So in fact, let's go ahead and try doing that. I'm going to take this expression, the distance moved, and is greater than move distance. I'm going to cut it out, and I'm going to put it as the return expression for the should platform return function. You notice it's going to complain here because distance move isn't a local variable within our should platform return function. So we're going to have to move some more things over. But before we do that, I don't want to forget to put a call to the should platform return in our if statement. So should platform return, and then remember to put the parentheses so the function actually gets called inside our if statement. So now it's starting to read a bit better to me. If platform should return, then we do all of the following. So now what we need to do is bring across the distance moved variable that we've got in move platform. We don't actually need it inside move platform. I'm going to cut it out and bring it and put it on the line before our return statement. Usually the return statement is the last thing in a function, because once you've returned out of a function, you actually don't do anything else. If I were to put something like a log message, so I'll put a ulog after my return statement with some sort of message, usually what's going to happen is you'll get a warning from your compiler saying that this line will never be reached, and that you probably didn't mean to do that. So the return statement usually is the last thing. So having moved across the line that defines the distance moved in our should platform return function, you can see it's now saying, hey, I don't have a current location. And well, the current location we can just very easily grab. We've set the current location just before we're calling should platform return. So actually get actor location is exactly what we want. So I'm just going to put that instead of a variable. I'm just going to put a call to get actor location in the place in should platform return. So now what we've got is the distance moved is equal to the effective distance between the start location and the get actor current location. So if that's greater than our configured move distance, then yes, the platform should return. That's what this function is saying, and it allows us to use it at a higher level of abstraction from within a move platform function. Now you'll notice that it's now complaining that we can't get the distance moved to print our overshoot. Well, that's no big deal. I don't actually want to print that anymore. It's kind of messing up my function anyway. So I'm going to delete the overshoot variable line. I'm going to delete the get name line. I'm going to delete the log message because it was only there temporarily, hence the log temp name. So now our move platform function is starting to look a lot cleaner. We can see that we are doing some updating of the location here. We can see whether the platform should return, and if it should, then we are updating the location and flipping it around. Now, one thing that I think would look a little bit better here is if we had an else statement instead of having this bunch of code up the top. So if the platform should return, we will execute this, else we will execute the normal code in terms of moving it forward. So remember, we cast your mind back to when we talked about the else statement. It just comes after an if statement, and we just do it like this. After the braces, we have a new line and type else, then another new line and open some new parentheses, and we can just move this code that's up here at the top of our tick. We can take it and move it down into the else statement. So now it seems pretty straightforward. Should the platform return, then do the code that does platform returning, else we're moving the platform forward with our platform velocity. Now I'd like to challenge you to create your own function with a return value. I'd like you to add a get distance moved function. So we've currently calculated this into a variable called distance moved. I'd like you to replace that with a call to a function instead. So it should return a float because that's how the type of distance moved. We should call it in should platform return. So instead of using the f-vector dist, we should be using our own implementation. So what code should it contain? What code should we put into it? The hint is that we've already typed this code, so you are just copying and pasting it into the new function. But have a little think about what the return expression should be, such that what we're returning is the distance moved value. Pause the video and have a go. Okay, welcome back. So let's go over to our header file. We'll add a new function here with a float return value. called get distance moved, and then we're going to have no arguments in the parentheses, and then we're going to go over to our moving platform CPP. We're going to add in a float, a moving platform, : distance moved, or get distance moved, I should say, parentheses, and then we'll put a new set of braces on the next line. And what we want to return is literally just the expression we're using to create our distance move float. So I can cut that out and paste it in here. So it's f vector : dist, start location, get actor location, and put semicolon at the end of that line. And that means that in should platform return now, instead of having this distance moved variable, I'm going to delete that line that's half completed. We're going to return get distance moved, parentheses, is greater than the move distance. So we've kind of taken what was going into a variable and pulled it out into its own function instead. And this means that whenever we want to refer to the distance moved, if we did want to have kept that log message in move platform, then we can easily just call the function get distance moved from any of the functions in our class. Great stuff. So in this lecture, we've learned about return statements and return values, and we've used them to create 2 new functions in our class. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be looking at the C++ equivalent of pure blueprint functions, which is const functions. We're going to see what this const keyword is, how we use it, and how it restricts what we can do in our code to make us safer. Let's dive in and see how it works. Over in Blueprint, we were able to make a function pure, and that meant that we could take away the need for the execution pins. Now, in C++, we can do something a little bit stronger, which is to make a function const. Now, what does it mean to make a function const? It means that that function cannot modify the state of your class, and it is actually enforced by the rules of the compiler. So let me give you an example. If I were to take our should platform return function, this is not a function that should modify anything in the class, and it would be an error really if we forgot that, because it would be weird if calling this and using it in an if statement actually changed the location of the platform, or if it updated the move distance or platform velocity. So to keep ourselves honest to that, we can make it const. And the way we do this is by putting the const keyword after the parentheses of the function. We often leave a space here as well. Now, in order for it to correctly match up to the function in the C++ file, we actually have to put that const keyword over there as well. Now, like I said, this now makes it an error to do anything that would modify the class. So if in should platform return I were to try and modify a class variable such as move distance, I might try and set move distance to 200. Let's see what happens when we go over to Unreal and hit the compile button. Okay, you can see that there's now an error. It does fail to build, and if you look at the error, you can see that there's something being said here about not being able to modify something because it's being accessed through a const pointer. Now, don't worry about that language, it's a little bit hard to interpret, but the point is the keyword const was there and it's saying it's not able to modify something. And that is crucial. Also, if you called any functions that aren't marked as being const, that's also a problem. So while it's fine to call getActor location, that is a const function, doesn't change anything, just gets the location, it's not okay to call setActor location. That hasn't been marked as const, and so it's not valid. It could be modifying the class. So any function that's not marked as const is not allowed to be called from within a const function. And so you can see a problem emerging. We can't actually call getDistanceMoved from within our should platform return, because should platform return is const, but getDistanceMoved hasn't been marked as such. So a quick challenge to you, get the distance moved const, make getDistanceMoved const. So in the header and CPP file, you're going to add that const keyword to let C++ know that it shouldn't modify the class. And does it compile now? Pause the video and have a go. Okay, welcome back. So we're going to go over to the header file first, and after the closing parentheses, we're going to add a space const, and then we're going to go back to the C++ file, and after distance moved parentheses, we're going to put space const. Now, the squiggly lines under get distance moved should update in a little bit of time, but if we go over to Unreal and hit the compile button, that will be the ultimate arbiter as to whether the compiler likes what we've done or not. And this time the compilation has succeeded successfully, which means that we have correctly updated our code. And that makes sense because there is nothing being called from getDistanceMoved that is not const. It's not trying to change anything. And where we are calling a function in should platform return, we are only using const functions. And this is a way for us to increase the safety of our code because functions won't be changing stuff without us knowing about it. Now, as a little exercise to yourself, you might want to go through and look at all the functions that we've been using up to now and see which one of them are marked as const and which ones aren't. You can do this by simply hovering over a function such as getActorLocation and seeing whether the pop-up that is included, whether after the parentheses it has const or not. You can see with getActorLocation, hovering over it gives me const. Hovering over getName also gives me that this is const, and it makes sense. Neither of those two should be changing the state of our class. Now, if I hovered over tick, you can see this one isn't marked as const, and that makes sense because tick is usually used for updating how a class is positioned in the world or any of the state of the class. And we've got our vector. If we hover over getSafeNormal, you can see that it's marked as const. That's because getSafeNormal doesn't actually modify the vector, it just returns a value with a new vector in it. So that's it for this lecture. We've learnt about adding const to our functions to increase the safety of our code. I'll see you in the next one. Hello and welcome. In this lecture, we're going to be making rotating as well as moving platforms. We're going to do this by learning about the frotator type in C++ so that we can add a little bit more of another element to our puzzle. Let's dive in and find out how this works. So let's talk about filling out our rotate platform function. So in order to do rotation, it's very similar to the way we do location, and we've got very similar functions we can call. Instead of calling getActorLocation, we can call getActorRotation instead. And if I go and put parentheses on the end of this line and just hover over the function, then Visual Studio IntelliSense is going to show us that the return value from this is an frotator. We've used the f-vector when working with locations, and we've talked about rotators in the previous sections. So let's have a look at putting this frotator into a local variable. So the type's going to be frotator, and we're going to call this the current rotation equal to the getActorRotation. Put a semicolon at the end of the line. I'm also going to delete the log statement because we no longer need that. And then what we want to do is essentially exactly the same as we've done with the platform velocity, which is a kind of rotational velocity multiplied by the delta time added to the current rotation. So what should that rotational velocity be? Well, that's where we want to go over to the header file and add a new U property. So I'm going to add it underneath the move distance, and I'm going to have a U property, edit anywhere, and then give it a category equal to, this time we're going to call it rotation, and I'm going to change the category name from moving platform to moving in both instances. So we're going to have a category for moving, a category for rotation. Then underneath the U property, we're going to put an frotator called rotation velocity. And we're not going to give it a default value here because by default, I don't want any of our platforms to rotate. So the default value is going to be 0, 0, 0, and that's just what we need. So I'm going to put a semicolon on the end of the line here. And now we can go back over to the C++ file and use that member variable in our rotate platform function. So what we want to do is current rotation equal to the current rotation plus rotation velocity multiplied by delta time, and put a semicolon on the end of the line. And now the final piece of the puzzle is to set our actor to that new rotation. So exactly as you would expect, maybe a little mini challenge for you in fact, is how would you go ahead and do that yourself? Well, what we would use is the setActorRotation function, and we would pass in an argument of current rotation, like so, put a semicolon on the end of the line. Now, unfortunately, it doesn't work quite as simply as this. It's come to my attention, some students have pointed out, and the teaching assistant, Dan, thank you very much, has pointed out that just adding rotations together like this won't always work because of some of the complications around rotations wrapping around themselves. If you go all the way to minus 90 degrees of rotation, at some point you need to flip over into plus 90 degrees of rotation and so on and so forth. So a better way around this, instead of setting the actor rotation, is to call the add actor local rotation, and you can notice here that there are a few add actor local transform as well, and local offset, that's for location, so you can use that as well instead of adding location. However, there aren't the same sort of problems that we're going to encounter in the edge cases around rotation, so what I would recommend you do is add actor local rotation here instead, and then you just put in the rotation velocity multiplied by the delta time, and it does the rest of this code automatically for you, so we can just go ahead and get rid of those lines, and you've got a straightforward addition to the local rotation going on here. And you can also get rid of this getting the current rotation because we no longer need that either. So let's head over into the editor and hit the compile button. And when that's done, close the log. Let's select one of the platforms in the level, any of them will do, and have a look at the categories. So we've got moving and we've got rotation, and we've got the rotation velocity there. So I want to point. And the reason for this, among other things, hello and welcome. In this lecture, we're going to be making rotate.
Oh, the .NET. Uh, do all this waiting 2 hours for it. But I'm studying. Do it in C++.
What you think about when you're born into a fire? Let 'em burn it out. Sell 'em to the richest buyer. They wanna let the world decay. They tell us lies and fade away, fade away. We feel betrayed. We were raised to lose the race. Wake at the back of the pack,
Now installation up to date, vamos ver. Ah, mano, vai tomar no cu, agora não reconhece nenhum anterior. Ah, velho. É que bagulho de merda do caralho. Inferno! Merda aqui. Inferno do caralho, filha da puta. Só preciso dele pra instalar os. Bosta. Uma bosta.
It's plain and simple, dear. I'll still be here when you're gone. You gather souvenirs, but I will never be your pawn. Your pawn. Your pawn. My love wasn't ever again.
Directly why it told me to install this fucking. They're on starving. Wow.
I'm spinning in a vicious cycle. I'm scared of doing something I'll regret. Maybe this is right, but I'm still staring at your silhouette. But what if you're everything I need? A fire in my heart, the air I breathe. What if I'm incomplete without you by my side? What if I go against my heart instead of confessing from the start? What if I miss out on the life meant for us? I need you by my side, by your side. I'm not afraid. We found something that'll never fade. We can be ourselves and figure out the rest along the way. What if you're everything I need? A fire in my heart, the air I breathe. What if I'm incomplete without you by my side? What if I go against my heart instead of confessing from the start? What if I miss out on the life meant for us? I need you by my side. I need you by my side. I need you by my side. Something's wrong, I feel it circling like vultures round my brain. Couldn't see this danger in your
Fuck!
Same story. You lose to love and glory. It's over. Same story. You lose to love and glory. You sing a pretty song to drag my heart along. A siren serenade. You're ringing out your prey. Your love's a wreck and you know it's wrong. It's over. Same story. You lose to love and glory. It's over. Same story. You lose to love and glory. Living every day in your head for free. You can tap away, but I will not hear you scream. You can break the keys, spread your toxicity. Your world outside reality. In your room, a little hideaway, but you let it through. Enough to go insane, living in the dark. Hasn't treated you well. You're building your own prison cell. Hey, wait, don't waste it on me. Spite, lies telling you, don't waste it on me. Did I brush you off? Is it your lack of friends? We never met. Even if you pretend, am I in your debt?
Just those.
You nothing, don't say something you'll regret. Hey, wait, don't waste it on me. Spite, lies telling you, don't waste it on me.
you